Right, in the exam, you're likely to get a counter-example type question where you need to prove that a statement is actually false, and it often involves the modulus function, okay? Now here you've got a minus b, the mod of a minus b is identical to the mod of a minus the mod of b. Now in this case, right, you might be wondering why they've got 3 lines there. 3 lines is a bit more special than equal, it means identical, okay? And identical because they're saying that this is true for every value of a and b. So you could pick any value of a and b, and they would, a minus b would be identical to a, the mod of a minus mod of b. This would work whatever you chose for a and b. Okay, you know, there are situations where it will work. For instance, you know, if you set a to equal 5, b to equal 1, okay, well, the mod of a minus b will be 5 minus 1, which equals the mod of 4, which equals 4. And then you've got mod of 5, take away the mod of 1, which would be 5, take away 1, which is 4. It works, yeah? The left side is the same as the right side, okay? However, it's not true for every a and b, right? And we need to show that. We need to find, when it says find a counter example, we need to find one example where this doesn't work, okay? And usually the way to do this is to show it by choosing a value for a that's positive and a value for b that's negative, okay? Or you could do it the other way around. As long as one of them is positive, one of them negative. So shall we go for a equals to, say, 7 and b equals to minus 2, all right? Now what I tend to do when I'm trying to show that they don't work is I tend to sort of use a bit of communication like this. So I say left-hand side. Okay, so what I mean by left-hand side, LHS, left-hand side, I'm going to look at this to start with. So I've got the mod of a minus b, so that would be 7 take away, right? A minus b is 7 take away, and then b, of course, is minus 2. Okay, so that will become the mod of, now of course 7 take away minus 2, 2 minuses become a plus. Okay, so I end up having the mod of 9, which is just 9. Alright, if I look at the right hand side, that will be the mod of a, which is the mod of 7, take away the mod of b, which is the mod of minus 2. Okay, now the mod of 7 is just 7, take away, the mod of minus 2 is 2, isn't it? Don't forget the modulus makes everything positive. So if it's minus 2, it becomes 2. So you end up having in 7, and the minus that's in place, take away 2, will give you 5, give you a different answer. So left hand side is not the same as the right hand side. So we found an example. That's what I mean by counter example. We've counted it. We've counted it. We found one value where it doesn't work. So you could say, therefore, statement false. Okay, now over here, we can do another one here. Again, right, you've got this. It looks as though they should be equal, but if you choose a value for a that's positive and a value for b that's negative, we show that it doesn't work. Left hand side will equal 4 times a, which is 5, plus 3 times b, which is minus 3. So that will equal to 4 times 5 is 20, 3 times minus 3 is minus 9. So that will equal to the mod of 11, which is 11. Okay, the right hand side, 4 mod of 5 plus 3 mod of minus 3. Of course, 4, now that just becomes 5, it stays as 5 when you do the modulus of it. So 4 times 5 is 20. And then the mod of minus 3, of course, it becomes positive 3. The mod makes it positive. So 3 times 3 is 9. So plus 9, 29. You can see they're not equal. Left hand side is not equal to right hand side. Therefore, it's important you say this, right? Statement is false. Okay, last one is you've got to think a bit more about this. It says it's an if and then statement, right? So it says if this is actually true, then this is true. Okay, so if we've got a plus 3 identical to b plus 3, okay, then A must equal B. So we've got to find a counterexample. Okay, so in other words, this can only be true, right? What they're saying is this can only be true when A is equal to B. Alright, so by finding a counterexample, shall we try and find a situation for A and B, numbers for A and B, so actually this actually works out, but A and B are different. Yeah? Does that make sense? Because they're saying, if this is true, then A has to equal B. Well, no, let's try and find a situation where A is not equal to B, and this is true. Alright? And it's not too difficult to do if you just think about what modulus does. It makes everything positive, doesn't it? It makes everything positive. Okay, so what you can do is just think about what value we'll aim for. Should we try and get this to equal to 10? Okay, try and get this to equal to 10. So what would A need to be in this case? Of course, A would need to equal to 7. Yeah? A would need to equal 7. Well, they'd be saying to us now that B would have to be 7 as well. However, we don't actually have to get this to equal to 10 for these sides to be equal. Think about it. We could actually get this to equal minus 10, couldn't we? Because if we got this to equal to minus 10, these would still be equal, right? They'd be identical, wouldn't they? Because when you do the mod, it makes it positive. So we set that to equal 10, so we got 7. But if we set this to be minus 10, we can work out what B is. Okay, so B plus 3 equals minus 10. That means B would equal minus 13. So we found a situation where this is false. Okay, in other words, A plus 3 is identical to B plus 3, but A is equal to 7, B is equal to minus 13. They're not the same.